All right, day 1, unit 8, unit circle stuff. But we kind of have to back up a little bit, like all the way back to geometry. The fun times you had as a 9th grader or 10th grader. Let's recall some of these special right triangles. So the 30, 60, 90 triangle. Does that sound familiar? Look familiar? Sort of. Do you remember the pattern that goes on that? Some teachers did it with A's, some do it with X's. Do you remember the pattern for 30, 60, 90? A bunch of no's. Do you remember if you used A's or X's? I can make it match. I'm going to use A's then. Across from 30 is A. Does that jog enough of a memory? Yes, no? Still no. Across from 60 is A square root of 3. And the hypotenuse I mean, you can do A squared plus B squared equals C squared, but what you'll find is that the hypotenuse is 2A. And then the other one is a 45, 45, 90. The other special right triangle. Do you remember the pattern on that one? Nothing. Clearly those have got to be the same since they're both across from 45. So those are A's. And then what's the hypotenuse? Almost. A square root of 2. So those two triangle patterns sort of form the basis for the unit circle. So let's actually do a couple of review problems based on that. To solve these, the best way to do it is to put the pattern on first and then match up what you can to figure out what A is. So across from 30, and this is how you remember it. You have to remember who's across from what. It's not like A is on the bottom. That doesn't work. A is across from 30. So that's 30. A is across from 30. Across from 60 is A square root of 3. And the hypotenuse is 2A. So A is 4, this side would be 4 square root of 3, and this side would be 8. Let's do a 45, 45, 90 triangle. And I like drawing them in with different orientations, just so you don't always start to think that A is on the bottom or 2A is on the right or anything like that. And for this one, let's say the hypotenuse is 8. And we want to find the length of the other two sides. So we put the pattern on there, A, and A square root of 2. So this one's a little bit harder. A square root of 2 is equal to 8. If you squared both sides, you'd end up with 2a squared equals 64. It wouldn't be wrong, it just wouldn't really be helpful. Let's divide both sides by square root of 2. So a equals 8 over square root of 2, which is
Just square both sides, or square the... No. Yeah.
Multiply top and bottom by square root of 2 to fix that. So 8 square root of 2 over 2, which is 4 square root of 2. 2 more examples, and these are the most important examples today. So 30, 60, 90, where the hypotenuse is 1. Hypotenuse is 1. So job 1, put the pattern on. A square root of 3, and 2a. So what does a equal? 1/2. And that means a square root of 3 would be 1/2 times square root of 3, or just root 3 over 2. Last one, then we'll do one more thing then we'll sort of switch to a different sort of subtopic of the unit circle. Why don't you try this one? So I'm going to press pause. It's 45, 45, 90. Hypotenuse is 1. Find the missing sides. All right, so put the pattern on. A square root of 2 is the hypotenuse. The other 2 sides are a. So if we can figure out what a is, we'll have our answer. A square root of 2 equals 1. So divide both sides by square root of 2. Multiply top and bottom by square root of 2. And a is root 2 over 2. So not too bad. Hopefully you remember putting the patterns on and finding missing sides. All right, if you're at home, you can print out the triangles that I posted and cut them up and do what we're about to do, or you could just watch, whichever. All right, now we've sort of done this problem already, like the 45, 45, 90 triangle. That's the problem that we just did. So let's label the other sides. Both of those were root 2 over 2. Root 2 over 2. And then the 30 triangle was the one before that. So I'm looking back at my notes. Across from 30 was 1/2. And across from 60 was root 3 over 2. And then that 60-degree triangle, it's really kind of the same as the 30-degree triangle, right? So it's got a different orientation, but across from 30 is 1/2, and across from 60 is still root 3 over 2. I know. Why are we labeling triangles? What are we going to do with these? Okay. Set those aside for a moment. We'll come back to them. Kind of jumping around, I know. Set that to the side. Now let's look at the unit circle.
Wait a second. These go on the unit circle?
They are going to go on the unit circle. But before we start putting them on the unit circle, despite the fact that all of you are now putting them on the unit circle, which is okay, the point of the unit circle is that this is the big deal with the unit circle, so you should put this at the top somewhere. R equals 1, got that. So that's going to match up with our triangles. We'll put the hypotenuse on the radius. They'll both be 1. That's not an accident. We forced that to happen. But the x comma y, like this is a point at the end of this pi over 6 marker here. That's a point, x comma y. But this is the big deal about the unit circle. That point is also cosine of the angle, comma sine of the angle. And that's the big deal with the unit circle, is this connection between the xy point and cosine, comma sine. So let's grab the 30-degree angle and slide it in there at the 30-degree mark, and it should fit just perfectly.
Well,
Our hypotenuse is 1, our radius is 1. So looking at what we've done here, what's the x-coordinate of this point? We just about have it labeled here. Root 3 over 2 is the x-coordinate of that point. Because we would go over root 3 over 2. And how many up would we go? What's the y-coordinate of the point? 1/2. Now, what we just discovered is that the cosine of 30 is 60 degrees, or the cosine of pi over 6 is, wait, did I say that wrong? The cosine of 30 is root 3 over 2. The cosine of pi over 6 is root 3 over 2. Because cosine goes with x, sine goes with y. By the way, they're alphabetical, just kind of like adjacent and opposite. We're alphabetical, x comes before y, a comes before o, c comes before s. That's just a fluke that makes things a little easier to remember. All right, let's grab the 45, 45, 90 triangle and slide that in there. So what's the x-coordinate at this point? Root 2 over 2, because we would go that many in the x direction. And the y direction, also root 2 over 2. That kind of makes sense maybe, because pi over 4 is right in the middle. So its x-coordinate and its y-coordinate should be equal. So this tells me that the cosine of 45 degrees is root 2 over 2. The cosine of pi over 4 is root 2 over 2. The sine of 45 degrees is root 2 over 2. The sine of pi over 4 is root 2 over 2. But rather than write all of those out, the circle helps us see all of those. All right, last one, the 60-degree triangle. Let's see. So what's the x-coordinate of this point? 1/2. We go 1/2 in the x direction. And how many in the y direction? Root 3 over 2. So what does that mean the cosine of 60 degrees is? What's the cosine of 60 degrees? 1/2. What's the sine of pi over 3? Root 3 over 2. All right, you will have to know, memorize, understand the first quadrant. After the first quadrant, you can usually, because of all the symmetry, figure out the rest. But the first quadrant, you have to know. Now, whether you memorize it or whether you kind of understand it and see some of the symmetries going on, I leave that up to you. But you're going to have to know the first quadrant. Let's see, which one do we want to do next? Let's do the second quadrant. So you can still use the triangles if you want. You kind of have to flip them around and make them do, flip them over. That's sort of upside down. There's my 60-degree triangle turned upside down. X is negative, y is positive, because you're in the second quadrant. We're going backwards. How far backwards would we go? Like, what would this length be? Yeah, and you can get it from the other side, or if you need to peek at your triangle, it's like, oh, look, it's 1/2, so this side's 1/2. But if we go backwards, it's negative 1/2. But it's still root 3 over 2 for the height, yes, because the y is positive. The x is negative, the y is positive. That's always the case in the second quadrant. So at 3 pi over 4, well, it's going to be the same, sort of the same values as pi over 4, but the x is negative and the y is positive. The x is negative and the y is positive. Same thing at 5 pi over 6 and pi over 6. There are lots of symmetry going on. The x will be negative. the y will be positive. And that's why I said you have to know the first quadrant. After that, you can figure it out because of who's positive and who's negative. Speaking of positives and negatives, third quadrant. Who's positive and who's negative in the third quadrant? They're both negative. So you can go back to the first quadrant or you can go back to the second quadrant, either one. But at the over 6 marker, negative root 3 over 2, negative 1/2. At the over 4 marker, negative root 2 over 2, negative root 2 over 2. At the over 3 marker, negative 1/2, negative root 3 over 2. In the fourth quadrant, who's positive and who's negative? X is positive, Y is negative. So for the over 6 spot, the X will be positive because we're going to the right, but the Y will be negative. So root 3 over 2, comma negative 1/2. At the over 4 spot, X is positive, Y is negative. At the over 3 spot, X is positive, Y is negative. And there's really only 3 values you have to know, right? There's 1/2, root 2 over 2, and root 3 over 2. And remembering which one goes where is usually not that bad, because if it's the middle angle, they're both root 2 over 2. That's the easy one. The one people get confused is the other two. So you can either memorize it, or what I think is easier is thinking about long sides or short sides. If you're at pi over 6, let's back up a minute. Over 6, over 4, over 3. I'm going to make an observation about the unit circle in general here. So over 6 is always the shallow angle. They should all be the same color if you used a highlighter. Do we use a highlighter in here?
No.
Okay, well, grab a highlighter from a friend, or you can borrow one of mine. I have some to loan out. And don't highlight all of them. Like, highlight all the over 6s one color, highlight all the over 4s one color, and highlight all the over 3s one color. Okay, there's a lot of information on the unit circle. You are responsible for all of it, but it's not like there's, I think someone counted there's 68 or 66 different blanks there, but they're very much related blanks. So if you know the first quadrant, you can figure out the rest. And even in the first quadrant, if you think about how I usually think about it, is long sides and short sides. So pi over 6 is the shallow angle. That means the x side is longer than the y side. But every x side is root 3 over 2, or every long side is root 3 over 2. Every short side is 1/2. Oh, we have the quadrantals. That's the fancy name for the quadrant markers. What's the radius of this circle? 1. So don't worry about angles. What's the coordinates of this point then? The coordinates 1, 0. Okay, we can do it that way. Negative 1, 0 would be on the other side. At the top would be 0, 1. And at the bottom would be 0, negative 1. Let's see. Positives and negatives. That sort of relates to the all students take calculus thing. So you can add that to the unit circle if it's not too gummed up already with information. That tells you who's positive and who's negative. Well, I guess I should say it tells you who's positive. In the first quadrant, sine, cosine, and tangent are all positive. In the second quadrant, sine is positive, which means cosine and tangent are negative. Third quadrant, tangent is positive, sine and cosine are negative. And in the fourth quadrant, cosine is positive, sine and tangent are negative. Now we knew that already, so that's sort of a different way of writing the same information. All right, we've mentioned tangent a couple times, but tangent is not on the graph anywhere. Like the cosine is the x-coordinate, the sine is the y-coordinate. So cosine of theta is the x-coordinate, sine of theta is the y-coordinate. Do you remember what tangent was equal to? It's TOA. So I guess we could start with that. But who did O and A go with? That's right here as well. So to find tangent, you do y over x. So you need both of them, the y-coordinate over the x-coordinate. Do a couple problems together down here at the bottom. I was going to flip it over, but then you wouldn't have your unit circle to look at. So, sine of 4 pi over 3, cosine of 11 pi over 6, and then tangent of pi over 3. Why don't you try those three? The first two should be easy, like just look at the unit circle and pick off the value. Tangent would be a little bit harder. So there's the answers to those three. Sine of 4 pi over 3, cosine 11 pi over 6, tangent of pi over 3 with a little keep it, change it, flip it. I want you to try two more. Tangent of 90 degrees and let's try something a little bit tricky. Sine of 13 pi over 6. Try both of those, and both of those have a little bit of a trick to them. So number 4, y over x, 1 over 0, that's undefined. 13 pi over 6, some people will claim that 13 pi over 6 is not on the unit circle. I kind of see what they mean, but what is on the unit circle that's the same place as?
Pi over 6.
Yeah, there's a coterminal angle if we subtract 2 pi. So pi over 6 has the same landing, coterminal, so it'll have the same x and y coordinate. So what's the sine of pi over 6? 1/2. All right, that's in some ways that's like it for the next month. But that's a lot of information. That's a lot to just say, okay, we're good now. So if you thumb through the packet, today's assignment's worksheet 1. But as you look through, most of the rest of the worksheets look just like worksheet 1 because it's more practice, more practice, more practice. So today is worksheet 1. We'll give you later I'll give you better hints on how to work some of these, but for now you can just kind of use the unit circle. We'll get to the point where we don't use the unit circle, but we're not there yet. Right now we just want to get comfortable with the unit circle.
What is this packet?